Hi, this is Mrs. Finnegan, and we're going to look at problems 46 and 47 on the Semester 2 final review. And these are exponential equations that we're going to solve. So ultimately, when you're solving an equation where your variable is in your exponent, what you want to do is you want to get that exponential term by itself. So you want to do all of your addition and subtraction and multiplication or division first to get the exponential term alone. So our first thing we're going to do then is, I notice I have e to the 2x minus 1 power. That's my exponential term. That's what needs to be by itself. So I'm going to get all of the other numbers away. So first I'm going to move the minus 3 by adding 3 to each side. Oops, that should be 11. Sorry about that. All right, so I add 3 to each side. So the left side now becomes 4e to the 2x minus 1 equals 14. Now I still have the 4 in front. The 4 is a multiplier, so I am going to divide each side by 4. Okay, so the 4's cancel out. Now I have e to the 2x minus 1 equals, I'm going to simplify, 14 over 4 is going to be 7 over 2, or you can use 3.5. I'm just going to leave it as a fraction here. Once I have my exponential term by itself, now what I can do is I can use log to get rid of the exponential term. So I can take the log of each side. I want to also pay attention to the fact that my base, exponential base, is e, so I'm going to use the natural log instead of log. So I'm going to take the natural log of each side of e to the 2x minus 1 equals the natural log of 7 over 2. So whenever I take the natural log of e, what happens is my exponent is going to move out to the front, because that's the power rule for exponents, or power rule for logs. So I get 2x minus 1 times the natural log of e, and that equals the natural log of 7 over 2. Whenever I take a log of an exponential base and they match, so natural log base is e and it have an exponential base e, it equals 1. So I can replace natural log of e with 1. So now my problem is a lot simpler because I don't have an exponent anymore. I have 2x minus 1 equals the natural log of 7 over 2. So now I want to get x by itself, so we're going to follow the same type of process. So I'm going to add my 1. So notice natural log of 7 over 2 is going to be its own term. Anything I do is going to be outside of the natural log. So it's going to be 2x equals the natural log of 7 over 2. And if you need to put it in parentheses, because you'll have to do that in the calculator, then the plus 1 is going to be added at the end, not inside the parentheses. Okay, last thing I'm going to do is divide by 2. So x is going to be the natural log of 7 halves plus 1, and everything gets divided by 2, the whole side. So you can put this entire expression in your calculator. Make sure you put 7 over 2 inside the parentheses after the natural log, and that everything is being divided by 2. So if you put that in your calculator, you're going to get an approximate answer for x, which is going to be 1.126. Okay, problem 47 is going to be very similar, except I don't have a base e, I have a base of a number, and there's a couple ways to deal with that, and we'll talk about it when we get there. But again, we want to look at my exponential term, and it's this right here, and I want to get that by itself. I'll deal with the minus sign in a minute. So first thing I'm going to do is I'm going to move the 8, so we're going to subtract the 8, so that gives me a negative 13 equals negative 2 x to the third. And remember, I said I want this by itself. I don't want the negative sign with it. So what I can do is I can divide everything by negative 1, which is going to change the signs of each side, giving me 13 equals 2 to the x divided by 3 power. Now I have my exponential piece by itself. So in order to get the exponent out of the exponent place, I have to use log. So I'm going to take the log of each side. Now, there's two ways to do this. I could take the log of each side, and my answer will still work either way, or I can make my log base match my exponential base. Since my log base, or my exponential base is 2, I could use log base 2. Just make sure that both sides are the same. Okay, so whenever you take a log of something, regardless of if the bases match or not, what happens is your exponent is going to come out to the front. That's the power rule for logs. So we get log base 2 of 13 equals x over 3 times the log base 2 of 2. So same thing, rule applies here, that I have a log base matches my exponential base, that equals 1. And so I'm just left with x over 3 equal to log base 2 of 13. Okay, last step, we want to get the x by itself, so I'm going to multiply each side by x. So because I have a log, sorry, not by x, I want to multiply each side by 3, because I'm trying to get rid of the 3 in the denominator. Sorry about that. So I'm going to multiply each side by 3. So I'm going to get x equals, let's put the 3 in the front, 3 times log base 2 of 13. Okay, so if we put that in our calculator, we're going to get x is equal to approximately 11.101. So again, your first step whenever you're solving an exponential equation is get the exponential term alone. So do all your other addition and subtraction, that's not part of the exponent term, done first. Then once you get the exponent term by itself, then use your log of each side, or natural log. And then the third thing is you're going to solve for your variable at that point. Good luck.